The next topic we are going to learn is describe Azure Compute and Networking Service. So let's quickly see what are the topics to be covered. We'll have introduction, describe Azure Virtual Machines, create an Azure Virtual Machine, describe Azure Virtual Desktop, containers, functions, application hosting options, virtual networking, configure network access, virtual private networks, ExpressRoute, Azure DNS, and knowledge check. So there are many things to learn in this video. So let's get started. Let's get an introduction. In this video, we are going to learn about compute options, in which we are going to see virtual machines, containers, and Azure functions. Similar way, we are also going to learn about networking features such as Azure Virtual Networks, Azure DNS, and Azure ExpressRoute. In the topic, describe Azure Virtual Machines, let's look at some key important points. Now, virtual machines, generally called as VMs. VMs are just like physical computers created in cloud. More like your laptop, more like your desktop, which is there in the cloud. When it's a cloud, the physical machines are there somewhere and you are trying to access it through the internet. VMs provide infrastructure as a service. So that means I don't need to have my own physical computers or setups. I am just taking it for a kind of a rent, right? I'm renting it. The amount of use I do, I will pay for it. So actually what I'm doing, I'm actually getting infrastructure as a service. Now what it is ideal for? When should I go for a VMs? Now with VMs, what happens when I go for cloud VMs? I have total control over the operating system I'm going to install. I want Windows 10, I want Ubuntu, I want Linux. Whatever is required, the kind of operating system that you need can be installed. You have total control over the operating system. And without saying, you also have control over the softwares that you install, right? How you host them, all the configuration, everything is in your control. Already created images, for example, I already have an image wherein I have a specific operating system, let's say Windows Server. And then I have installed certain softwares for the developers to work, right? So I have already created a VM. Now already created image or OS software to provision new VMs. Now I need another 2 such VMs. Now it becomes absolutely easy. In matter of minutes, I can replicate the VM which I already have configured. So that is the possibilities, that is the features that you get from cloud. Now scaling. Now scaling is an important part. Now what does it mean by scaling? Let's have a look. Now when I'm using a single VM, it's all fine. Whenever I need more VMs, what I can do, a similar VMs, I can group them. So there are two important terms that I need to be aware. One is scale sets and the other term is availability sets. These are very important. What is it? Scale set. So this is nothing but grouping of VMs. For example, I need 4 developer VMs. So I can group them in one. And tomorrow I need few more. And after a month I need less. So based on my need and demand, I can scale it. Scaling means going up or down, right? Number of VMs you need more, less number of VMs you need. So scale sets, and there is something called availability sets. These are very important terms here. Let's understand what is a scale set. Now for scale sets, it is very simple. The number of VMs instances can automatically increase or decrease in response to demand. The moment it finds there is a huge amount of, for example, think in a production environment where I am currently running my application on 2 VMs. Tomorrow, because there is high demand, all of a sudden the number of users accessing the site has gone high. In that case, what I can do, I can simply enable this automatically scaling up. So the Azure will automatically increase or decrease the VM based on the demand, number of VMs required at the moment. And after some time, the need has gone down, so it will automatically scale down. All these things can be done. So this is called scale sets. Or you can set it to scale based on a defined schedule. For example, on a given time, for example, from 10 a.m. till 4 p.m. or 6 p.m. I need so many VMs. After that, it should go down. So all this is a feature. Okay, this is more kind of an option or a feature that is available on Azure. Next, moving on to our next grouping called availability sets. Availability set is another tool to build highly available environment. Now with the word available, it is very clear that my VM should be always available even though there is a failure. So VMs are updated at different times and connected to different power and network sources. Now power and network sources can, if there is a failure, all my VMs can be down. To avoid that, what is being done? There are certain groups formed. Let's say I've got 10 VMs. I would have some 3 and 4 VMs connected to different power sources and different network sources. So if something I'm losing in between, right? So I have another power backup. So not all my VMs are going down. So you won't lose all VMs if there is a power or network issues are updated at different times and connected to different power and network sources. So the things that I marked in yellow are the important points to remember. All right, now how is it achieved? So there are two different ways. One is update domain. So what is update domain? Group of VMs that can be rebooted at the same time. So if I have to update my VMs with a new security patch, or I have to update the operating system, I have to update anything, right? So I made a group calling update domain, group of VMs that can be rebooted at the same time. Only one group is updated at a time. Let's say I've got 3 groups. So one group I'm updating at a time with a 30 minutes recovery window before moving to the next group. Pretty simple. So this is called update domain, or it's a group of VMs to update your systems. The second way to achieve high availability is fault domain. These are the key important terms to remember for the exam. Fault domain. VMs are grouped by power source and network switch. At one case, the VMs are grouped based on the rebooting. So that's how I have grouped it. The other one is grouping the VMs based on the power source and network switch. VMs are grouped by power source and network switch, splitting them across up to 3 fault domains to avoid losing all VMs during power or network failures. Imagine I have got some 9 VMs, so I'm having 3 fault domains, wherein in each fault domain I have 3 VMs. If any sets goes down, there are still other 6 VMs, right, which act like a backup for me. So the word availability is the important term. Why are we doing all this? To ensure the VMs are available. Next, let's understand when to use virtual machines. That is the question that might come. For example, I want few VMs for my testing and development. So in Azure, it becomes quite easy to create and delete VMs once I'm done. One more thing, for example, I want to run applications in the cloud. So I don't know for how many days I have to use or what it is, and I don't know how the business would go. So instead of setting up my on-premise setup, I would rather use it on cloud. I can save some money. I can start and shut down the VMs based on my demand, right? I'm going to pay only for what I use, so I can save some money. Let's say I already have a data center where my application is running. Now use Azure VMs to run applications, reducing cost and complexity compared to on-premise setups. So you can think of shifting from your on-premise to a cloud data center. Disaster recovery. For example, these application has to run on my on-premise data center. However, During failures, becomes very important that I have to still provide service. So run critical apps on Azure VMs during a data center failure and shut them down once the issue is resolved. So you can see I can solve a problem and then shut it down once I'm done and save some cost instead of keeping the application or the business entirely down until it is getting fixed. So these are some of the areas where you can think of you go for a virtual machine. Moving to the cloud with VMs. Now VMs becomes an ideal choice when you think of migrating from the physical servers to the cloud. So the term that we have already heard about, lift and shift. Whatever you have it on your physical servers, you can lift them and shift it to the cloud VMs. Now it's easy to transit. You can create an image of that physical server and run it on a VM with minimal changes. It's pretty easy when it comes to migrating from physical servers to the cloud VMs. And only responsibility that you would have is to maintain the virtual machine OS, because in the virtual machine you are the one who is selecting what OS is needed, what software is required inside the VM. So that means you are also responsible to maintain the softwares, the patches, the updates and things like that in the OS. These are the two things that will come as a maintenance. When building or provisioning VMs, you get multiple options. Like I can select the size, how many number of processors I need, how much RAM I need, storage disk. Should I go with hard drives or should I go with solid state drives? Networking options, for example, should I use the virtual networks the configure the virtual networks, public IP addresses and ports. I can go through multiple various options during provisioning a VM or building a VM. Now it's time to go through the exercise, create an Azure virtual machine. For this, I'm back to describe Azure Compute and Networking Services, and let's scroll down to this one where it says create an Azure virtual machine. I'm going to click on this and wait for some time. It is asking me to verify your account. Okay, let's start the puzzle. Match the number of rocks with the number of on the left. So 4 rocks. So let's see, where is the 4 rocks? 4, 5, 1, 2, 3, 4. Okay, so this is the correct one. I'm going to submit. So verification complete. Now let's wait. Checking the sandbox availability. Okay. Okay, I see the sandbox is now activated. Time remaining 59 minutes. So in this prompt, I am going to click on bash. No storage account. I'll leave it as it is. And I'm going to select my concierge subscription and click on use an existing private. Don't leave it. I'm going to click on apply. So the cloud cell is succeeded. Let's try out the exercise. In this exercise, we are going to create a Linux virtual machine and then install a software called NGINX. Now, NGINX is a popular web server software. Pretty simple. So, creating a virtual machine. Now, to create a virtual machine, I am going to use this particular command. All I have to do, copy this, go to the cell and use the keyboard shift and insert. Okay, shift insert. Control V will not work. Shift insert and hit enter. Now let's wait for few seconds and you can see the code is currently running. You can see that it started running the script. From here, this will take few minutes. We have to wait. So you can see the entire code has completely ran. Now what is the VM name we have given in this code? My VM. Now if I go to portal.azure.com and refresh the page, now there is nothing, no VMs I can see. Let me refresh the page. Okay, now you can see the VM is available. Okay, now if I refresh the page again and click on all resources, okay, now you can see the VM, the disk has been assigned, a lot of things happened behind the scene. Now this last time we have created the VM using the create option directly from the portal.azure.com. Create resources and did this, and this time we used a command to create a VM. Now after this is created, your VM takes few moments to come up. You named the VM as my VM. You use this name to refer to the VM in the later steps. Now this is the second step where I am actually installing one extension, or I am installing that ng-inx software. Okay, so this is the entire command. So this ng-inx is available in GitHub. Okay, ng-inx.sh, and this is what we are going to install and configure. Now for this, at this moment, you don't have to literally understand the code. All you have to do is simply copy this, experience how this works. Now once you copy it, you should get a tick mark, come to the command line interface or CLI, shift, insert, and hit on enter. Now give it a few moments for it to complete. Okay, it started running. Okay, now meanwhile let's read this. This command uses the custom script extension to run a bash script on your VM. The script is stored in GitHub. While the command runs, you can choose the examine the bash script. So what is the exact code we have written? This code is to update, to look for the new update for that ng-inx software, and then once it finds the update, it is going to install that. That's, and set the home page. You don't have to literally understand the code at the moment, but just leave it just to get a bit of understanding. And finally, what happened? The installation is complete. So with this exercise completes. Okay, let's wait for this to complete. Okay, now I can see this is now complete. Okay, the installation and everything has happened properly. This exercise is complete for now. The sandbox keeps running, and you come back to this point in a few units to update the network configuration so you can get to the website. Okay, so this is what we have done. So the VM is created with the Linux operating system, Ubuntu, and then we have installed a software inside that, which is nothing but ng-inx software, which is a web server software. The next topic is describe Azure Virtual Desktop. What is a virtual desktop? The Azure Virtual Desktop is a cloud-based desktop and application virtualization service. That means, for example, the moment you buy a Windows desktop laptop, for example, okay, so Windows laptop, I mean to say. So when you buy it, you have the operating system, you have few Windows applications inside that and things like that, right? Similar way, Microsoft Azure, in there you can also use the virtual desktop. It's a fully, you don't have to install operating system and a lot of things you don't have to go through. You simply pick and use it. A cloud-based desktop and application virtualization service. So it is a Windows based. So you can access full Windows environment from anywhere. All you need is internet and a device. So you can, most of the things, most of the companies that you already working or would be working, they would provide you the virtual desktops to work for the client. So these desktops might be coming from any of the cloud service. Similar way, Azure has its own virtual desktops. Cross device compatibility. So doesn't matter what kind of a device or operating system that is running. For example, I might be having a Mac operating system laptop. Somebody might be having a Linux based, somebody having a Windows based. Doesn't matter what device I'm having, what operating system I am having. All I can do, I can simply access it through the browser or by installing certain applications. Okay, so cross device compatibility works on various devices and operating systems. Access desktops using apps or modern web browsers. Using a browser or an app, I can simply access the desktop. I would also recommend you to watch this video on Azure Virtual Desktop. One of the best part of Azure Virtual Desktop is enhanced security. You have multi-factor authentication, secure user sign-ins with an added layer of authentication, role-based access control, assign specific access permission to users for better control. You can control the user accesses. The best part is the data protection. Now what happens here? Data and applications are hosted in the cloud, minimizing the risk of sensitive information being stored on local devices. You getting it? If I'm using my own local device, I might store a lot of files for lot of documents on my local drive. So that is a risk of data security. So that's where the virtual desktop gives you that data protection layer. You are minimizing the risk of sensitive information being stored on local devices. One of the interesting feature of Azure Virtual Desktop is multi-session. Now, what do I mean by multi-sessions? So multi-session support means I can use, uh, let's say I logged into a virtual desktop, which is having Windows 10, for example, or Windows 11. At the same time, another user can also use the same VM resources. So multiple users. Now on our laptop, if I use it to my user account, let's have created multiple user accounts. At a time, one user can log in. Now this is interesting with Azure Virtual Desktop, wherein multiple sessions are allowed for multiple users on a single virtual machine. So your hardware resources remains same, but there are multiple users trying to access the VM at the same time. This is interesting and this is very powerful. Next is broader application support. It provides better compatibility with more applications compared to Windows Server OS. So there are a couple of interesting features and advancement available with Azure Virtual Desktop. You will hear another term called Azure Containers. Now let's understand what is Azure Containers. For that, we have to go a little back onto our virtual machines. Now virtual machines you're using so that you can reduce hardware cost but are limited to running a single operating system per VM. So every VM you can only have one single operating system, correct? But anyways, it's helping you to reduce your cost, overall cost of managing and maintaining your own data center. Now what is this container? Now containers are, this will allow multiple instances of the same application to run on a single host. Host means single VM or single resource. Okay. So single VM, I can run multiple instances of the same application, making them more efficient and scalable. So this is, the containers are the upgraded version of virtual machine. How do you use a virtual machine? More like your desktop. It has a single operating system. You open a single instance of the app and use it. But here the containers are more advanced version of the virtual machines. So what are that? Let's understand little through examples. Now we heard containers allow multiple instances of the same application to run on single host or single VM. What does it mean? For this, let's take an example of, let's say you are having a business of online food delivery. You have an application, online food delivery application, and that application currently hosted on a VM, on a virtual machine. So you run a food delivery app that processes food orders from customers. Now without containers, that means you are running it on a VM. Okay, just forget about containers. So without this, you are running on a VM. You have one instance of this application running on the one host machine or one VM. So you have hosted the server and there it's running. But the limitation with that, this instance can only handle 500 customers requests at a time. At a time, it can handle only 500 based on the number of resources, CPUs and things like that. It can handle maximum of 500 customers requests at a time. Now, when the number of customers increases beyond 500, the application will crash or slows down because it's overloaded. Hence, you can go for more VMs. So what is the solution for me now? I know this is happening regularly, so I will procure more VMs to run more instances of the app. So one server application is running on a VM. Similar way, I'll replicate. I'll copy the VM into another two. So total three, for example, I have. Hence, you can go for more VMs to run more instances of the app, but this could be costlier due to high number of resources, right? This will become costlier for you. Now, what is the easy way where I can save some cost? So the answer to that is container. So container is another form of technology through which you are hosting multiple. So here what I'm doing actually, why I'm having another VM? I'm having another VM so that I can run more number of instances of the app. For example, currently in one VM, the instance is running. I will have another VM where the same instance will run. So instance 1, instance 2. So what do you mean by instance? So for example, you're opening an application. For example, you opened take an example of any application that you have on your system. Okay. So you open one application on your system. So that is running. That means it is a instance of an application. Now a server application you have already running on a VM. Now you wanted to run the same application on another VM to balance the load when there is a higher customer demand. So that is called an instance. You are running the same application on multiple VMs. So to save the cost, the solution is container. With containers, how it works, let's see. For example, you have packaged your application into a container. Now, how do you package it? All these things are a later part of the subject. Okay. Now let's understand you are started using container. How to use container? A lot of things are there. Now let's say you started using container and deploy multiple instance of an app on the same host machine. So here, what is the benefit? I don't have to go for 3 VMs. In that example, what we were discussing, I will only have one virtual machine. Remember, I'm only having one virtual machine where I'm running 3 instances. With containers, that is the savings, right? So how it works, the instance 1 handles the first 500 requests, for example. The instance 2 handle the next 500 requests. Instance 3 handles another 500 requests, and so on. So now what is happening with container, right? All these instances share the host machine OS. Now that is the beauty. That is the technology. So I am having one virtual machine where I am having one operating system running. However, I am creating instances in a way using this technology called container, Azure containers, wherein using the same VM I can run multiple instances. Okay. So how they are running? They are isolated from one another. It is more like as you are isolating. If I go with 3 VMs, in the 3 VMs applications are running individually. The similar experience the apps will have in one VM. That is the technology. That is the beauty of the technology. Using one OS, I am running multiple instances. Now, if one instance crashes, the others keep working, ensuring uninterrupted service. So that is the beauty of Azure containers. So why containers? Now containers are very, very efficient. Why? How they have become efficient? Because containers are lightweight. So you can run many instances on the same machine. That is the technology. I can run multiple instances of the application on the same machine without needing a lot of resources. Okay, it's a lightweight technology that we are going to see how it works. But here at the moment, let's understand the concept. Scalability. During peak hours, for example, the example we considered, the food delivery app like lunch, dinner, during that peak hours, you can spin up more instances to handle the load and scale back down when demand decreases. You getting it? So this is the beauty of the technology. Reliability. If one instance fails, other keeps running. So customers don't experience downtime. So that's about the Azure containers. Next, let's see what is Azure Kubernetes Service, or popularly known as AKS. Azure Kubernetes Service. Now what is this? Azure Kubernetes Services is a service that helps manage and coordinate a large number of containers efficiently. Just now we saw the example of containers. Now this is actually a container orchestration service. What is it? How to use it? Anyways, we're going to learn. This is more of a concept. So remember, the technology that is used to manage the containers, right? That is known as Azure Kubernetes Service or AKS. Now the purpose is it simplifies the management of containers, making it easier to deploy, scale, and monitor them. So everything is done through Azure Kubernetes Service, which we are going to learn later. Let's understand it in little more detail. So we are using containers in solutions, or we are using containers for running multiple instances of the app. There's a term for it called microservices architecture. Now, what is this microservice architecture? Let's understand. It breaks down an application into smaller independent parts. It breaks down your application into smaller independent parts. That's called microservice. Now you need an example with each part running in its own container. This container think like a box. It is running in its own box without impacting the other. So breaking down the application. So what does it mean? Let's see it. Now let's take an example of a website. We were talking about the food delivery website. Now there is a front end for the user interface, for the users to use it. Now there is a backend container for processing data and business logic. Okay. And then there is a storage container for saving the retrieving data. So there are three containers as a basic example we have taken. So when I divide my website or my application into three manageable parts, front end, back end, and storage. So this is called a microservice. You are breaking an application into smaller independent parts. Now, why are you really doing it? Why are you using a container and Azure Kubernetes service to manage them, manage the containers? So the best part is scalability. Now imagine if the backend container is overloaded. You can scale it up without affecting the front end or storage container. So you have individually you have kept different containers. If something get overloaded, you can increase, scale it up, scale it down, whatever is needed. You can work on a single container without impacting the other containers. The front end, if I do something in the front end, the customers would start finding it slow. They will find it is creating errors and things like that. You getting it? So that's why this architecture, microservice architecture, where you are breaking into smaller manageable containers. Flexibility, you can update or change one container, example front end, without disrupting others. So that is the benefit you get, the flexibility you get. Efficiency, the Azure Kubernetes services ensures all containers work together smoothly. Now what is AKS doing here? AKS is managing everything, right? AKS ensures all containers work together smoothly and adjust these resources based on demand. Now for sure you got a concept of the containers, but you haven't seen how it works, where you create the containers, how do you create it, how do you manage it using Azure Kubernetes services. All these things we would learn it later. At the moment the concepts are important for us to know. When we get introduced it to work on that, then you will be able to correlate of what is a container is and how you are using the Azure Kubernetes services. The next topic is Azure Functions. Let's see what is Azure Function. Azure Function is a serverless service that runs code in response to specific event or triggers. Now there are so many keywords which may not make much sense. For example, serverless, runs the code in response to specific event or triggers. What does exactly it mean? Now let's see through an example. So serverless means you don't have to manage or maintain servers for it. Azure handles all the underlying infrastructure, so you can focus only on writing the code. Now exactly, still you need more examples to it. So let's see, serverless means without you having or manage or maintain a server. Okay. runs code with respect to events. Your code or function is executed automatically when something happens. Now, this might bring it to a confusion state. Let me give you an example to make it more clear. For example, auto sending a welcome email. Now, let's see a scenario. You run a website where users sign up with their email addresses. After signing up, you want to send them a welcome email. Now, this is a function. When anybody signs up to your website, you would like to send out a welcome email to them. Now, without Azure Functions, let's say you do not have Azure Function, how would you really do it? Now, to do this, you would need a server running 24/7 to monitor signups. Correct? You need a server or a VM whose job is to monitor 24/7 to see how many people have signed up. And then the server would periodically check for new users and send emails. Even if no one sign up, just imagine there is a day or there are many hours where nobody is signing up, and you still pay for those servers to stay online because it has to run 24/7. Now, what happens with Azure Functions? Now, if you have Azure Functions, a trigger is set up to listen for new signups. When a user adds their email to the database, for example, when a user has added and submitted, so it gets added to your database. The moment it comes to your database, when a new sign up occurs, the Azure function is automatically waken up and runs the email sending code. So there is a code to send email, there is a structure, you have written a code, and it will automatically run that code for you. You don't have to run a server for it. After the email is sent, the function stops and you are no longer charged. So you are only getting charged for the amount of time you are using it, the resources, like the CPU. Here you are using a CPU for which you will be charged. So that means you are not charged. Let's go back to our first slide. So Azure Function is a serverless service that runs code in response to specific event or trigger. So we saw the example when somebody signs up, that is an event, that is where the code will start running, runs the code in response to specific event. So when somebody signs up, the code runs and it sends out an email. And serverless, that means I don't have to manage my own virtual machine, which has to run 24/7. So that is about Azure Functions. Let me give you one more example. Let's say daily data cleanup. The scenario is a company wants to delete outdated records from its database every night. Now, how it works? A time trigger activates an Azure function daily at midnight. The function queries the database and deletes old data. Now, why to use Azure function? Now you can see the benefit. No need to keep a server running for this once a day task. This is another example of Azure Functions. Now let's see some benefits of Azure Functions. Now Azure Functions focus on code, not on infrastructure. You only need to write the code for your service. We saw the example of sending out an email. Azure handles the platform and infrastructure. You don't have to build up a server, spin up a server for it. Azure would automatically handle things. Event-driven execution. It runs in response to triggers like certain REST requests we have got, certain timers or messages from other Azure services. That's time the event is getting automatically triggered. For example, signing up. The moment a record is inserted into database, I am triggering the function where the function triggers and it sends out an email to the new signed up user. Automatic scaling adapts to variable demand, scaling up and down based on workload. Okay. Cost efficiency. Now the important part is here. You only pay for the CPU time used while the function runs. For example, the function runs for an hour, so you pay for that 1 hour with no charges for idle time. Getting it? Stateless, and there's another two important things. The Azure Functions work in two different ways. One is stateless, stateful Azure Function. So what is this? Stateless means when they are stateless, this is a default Azure function. they behave as if they restart every time. For example, sending email. It will just check a new user have signed up, and then it sends out an email to them. So there is a specific format, a default format. It keeps on sending, right? It restarts every time whenever the function starts. Now there is something called stateful. So for this, you got an example of email, stateless. It doesn't wait for to check any other state. It just sees if a database has got a new entry, a signed up entry, it starts sending out an email. Now what is stateful? This is called durable functions. When they are stateful, called durable functions, a context is passed through the function to track prior activity. So the important words I have highlighted. Function to track prior activity. So let me show you one example, okay? A real world example. For example, online order processing is a stateful Azure function. So what is this online order processing? Now, an e-commerce website needs to process customer orders. The workflow includes multiple steps. For example, validate payment. So until a payment is paid, you don't want to ship the product to the customer. And then if the paid is done, then it checks the inventory, right? Or it notifies the inventory management team the product has been placed order, ensure you keep it ready. And then prepare the shipment. Then prepare so all this state is dependent on the previous state. If you see, inventory checks will only happen if the payment is already done. Shipment will only happen if the inventory is available, right? You will notify the customer about the shipment only when the shipment has started. So every state is dependent on the previous state. So in this case, the stateful means you are checking the previous state. So the Azure function will check the prior tasks. If that is fulfilled, then it will continue the next task. So these are called stateful Azure functions. The next topic is describe application hosting options. Now, what are the hosting options so far we have seen? We have seen one of the hosting option available in Azure is virtual machines. Now, virtual machines provide a maximum control over the hosting environment. It allows you to install your own OS, allows you to install your own software, and enable the settings as you need. This is one of the very familiar option when someone is transitioning from on-premise data center to cloud. It is ideal for hosting traditional and monolithic applications. Now the word it has come, monolithic applications, or applications requiring custom configurations. Now what is monolithic? Now monolithic means it is a traditional way of designing software where all the components of the application like user interface, business logic, database are tightly integrated into a single code base. The old way, the old school. Okay, so the monolithic application. Now we also learned about containers. Containers are lightweight and efficient alternative to VMs. We saw it in the previous set of topics. It enables isolation and independent management of application. It is excellent for hosting microservices. See, these are the two terms, monolithic and microservices. And when you need portability and scalability. So microservices means you are running the various instances of the applications in the same host machine that we saw during the container topic. Quick to deploy and scale, making them suitable for modern cloud native applications. There are other hosting options available on Azure. Now what are they? They are called Azure App Service. What is the name? Azure App Service. Azure App Service is a fully managed platform as a service offering that allows you to build and host web apps, background jobs, mobile backends, RESTful APIs. So it is a fully managed platform as a service. Now what is the key benefit when I say platform as a service? You don't have to manage or take care of infrastructure. So infrastructure means your resources that is utilized in the infrastructure, the OS, the software, all of the things you don't have to manage. It will be taken care by the cloud. It will be taken care by Microsoft. Okay, so letting you focus on developing and deploying your application. All you have to do, leave all the worries, all you focus is developing and deploying your application. So Azure App Service is another term that we're learning. Okay, Azure App Service. Let's learn few more things about Azure App Service. Now, what is Azure App Service? So build and host apps. So Azure App Service supports web apps, APIs, mobile backends, background jobs. That means you can develop any kind of application and deploy it. Language support. It gives you all different development platforms like .NET, Java, Python, Node.js, PHP, Ruby, and many more. Okay, infrastructure free. No need to manage servers and configurations. Automatic scaling handles traffic spikes with ease and ensures high availability. Now, what is Azure App Service? How to use it? Those things we are going to learn. This is more like an introduction that you know there is something called Azure App Service apart from the VM and containers. Cross-platform support, compatible with both Windows and Linux. Seamless integration with GitHub, Azure DevOps. Let's say your codes are there in these repositories. All you can do is you can sync those codes from your code repository, so you can go with a continuous integration and continuous development, CI/CD. So this is another thing that we are learning is Azure App Service. The types of app services in Azure. Azure App Service provides a platform to host various app styles catering to different application needs, all while managing infrastructure for you. So what does that mean? The key types of app services. One is a web app, host modern web application. The other one is API apps. These are the services. So if somebody asks in Azure App Service, what you can do? So you can host modern web applications. API apps run RESTful APIs for communication between systems. Web jobs execute background processes or scheduled tasks. Host mobile backends to power mobile applications. These are the couple of services that you can do by using Azure App. Let's see things in more detail. For example, web apps. Now in web apps, host web applications using ASP.NET, Java, Ruby, PHP, Python, and many more language support. You can choose Windows or Linux as the operating system. You are getting options to choose various operating system on which you would like to do the web app hosting. Now API apps. You can build REST-based web APIs with any language or framework. There is something called Swagger. All these things you are not aware, that's okay. But remember, for when it comes to API, there is something called Swagger on which you would see all the different APIs for an application. So features Swagger support and the ability to publish APIs in the Azure marketplace. API can be consumed by any HTTP or HTTPS clients. Similar way, web jobs. In web jobs, you can run background tasks or scripts like .exe, PowerShell, Bash, Python. So these are the different features. Good to know. Can be triggered or scheduled. Integrates with web app, API, mobile apps to handle background processes. And another feature also we saw about mobile apps. Mobile apps quickly build backend for iOS and Android apps. So this is the feature you get. If you have to build an application, not just a website, I also need a application. Nowadays, things are going on to mobiles, right? So quickly build a backend for iOS and Android apps. And then store app data in cloud-based SQL databases, enable social provider authentication like Google authentication when we log into any application, sign up to an application. You don't have to literally go to that old school of entering all your details. You can just sign up with your Google account. You can sign up with your Facebook account. Right? So all these things, options you get. Nowadays you have the number. You just enter your mobile number and you get an OTP and you are done. Send push notifications, execute backend logic, C#, Node.js, right? You get software development kit. SDK means software development kit. Support for iOS, Android, Xamarin and React Native. The next topic is describe Azure Virtual Networking. Do not worry, we are just getting introduced to many things that is there in Azure. Okay. So Azure Virtual Networks and virtual subnets. Now you may or may not be aware of networking concepts. It's still fine. Just learn the topic. Okay, just see what it is. Learn the term. Azure Virtual Networks and virtual subnets enable Azure resources such as VMs, web apps, and databases to communicate with each other. So why you need a network? To communicate. Each device has to communicate. Now you have, when say I have a device as a user, now if I'm typing something, it should communicate with your VMs, with your CPU, with your application, correct? With each other, with users on the internet and with your own on-premise client computers. So networking is all about that. Now this has got certain key features, okay? One of the key feature is isolation and segmentation in Azure Virtual Networking. Now, what is this isolation and segmentation? So I can create multiple isolated virtual networks within Azure to keep your resources separated. Isolate means different. I can create multiple isolated virtual networks. Set up a private address range using either public or private IP address ranges, available ranges that isn't accessible from the internet. So why I'm making it virtual and why I'm making it private, so that it is secure. Only I can access, for example, only I should have access to my resources. Divide the address space into subnets and assign. These are all networking terms. If it doesn't make more sense, it's okay. Just see if you can grab few things from here. Divide the address space into subnets and assign paths to different areas of your network. This is again a subnet is again a networking concept. Use Azure's built-in name resolution service or configure your virtual network to use your own DNS server for more control. So built-in name resolution service. So I would like to give specific names to my specific resources or devices. I can do that. The next key feature is internet communications. So you can enable the internet access if your application is, for example, a public application like Facebook, Google, or any application which is public. The public supposed to use it, for example. Enable internet access to Azure resources by assigning a public IP address to the resource. You can alternatively place the resources behind a public load balancer. Now, what is a public load balancer? All these elements you will learn, okay? But right now, just take it as a term. Load balance. It will balance the load of the traffic coming from the internet to manage incoming traffic from the internet. Let's see some other key features quickly. Communicate between Azure resources. When I say Azure resources, just think of virtual machines, your databases, things like that. Okay, so virtual network connect Azure resources securely, while service endpoints link resources like SQL databases and storage for better security. So important word is service endpoint, virtual network. So what is virtual network? Is all about communicating with different resources, right? Different devices. Next, how do you communicate with on-premise resources? Right, I am extending my data center and I am using on-premise. I am also using cloud. In that case, how it works? There are three mechanisms for you to achieve connectivity between your on-premise devices or resources and Azure resources. How you do it? First is there is something called point to site VPN. So point to site, VPN means virtual private network. Virtual private network. Point to the site. So for example, securely connect external devices to Azure via an encrypted VPN. So on my premise, I have a computer. I want to connect to cloud resource, to a VM I want to connect, for example. Now for that, I'll use a virtual private network and connect to my VM, which is there in cloud. So I'm connecting from a device to another resource, another device in the cloud. So that is called point to site. Point means one point to the site, the Azure site you are connecting. Okay. Next is site to site. That means many complete link your on-premise VPN devices to Azure VPN Gateway. So you have certain on-premise VPN to VPN you are connecting. So that is called site to site. The other thing is Azure ExpressRoute. So point to site, Azure ExpressRoute. This provides a dedicated private connection to Azure, offering higher bandwidth and enhanced security without going through the internet. So ExpressRoute, we have seen the roads nowadays, right? Express route. So in that, you directly go from one city to the other city without any stoppage. Express. Similar way, without going through the internet, you can, you have a dedicated private connection to Azure. Okay, so that is called Azure ExpressRoute. Let's see some of more key features. Route network traffic. So by default, Azure routes traffic between subnets, connected virtual networks, on-premise networks, and the internet. You can control and customize routing through the following methods. So there is something called route table. Route means how would you like to channelize your traffic coming from the internet, coming from your from your company and things like that, right? So route table, define custom rules to control how traffic flows between subnets. Broader gateway protocol, so there is something called BGP. Use BGP with Azure VPN Gateway, Azure Route Servers, Azure ExpressRoute to propagate on-premises routing to the Azure Virtual Networks. Azure Virtual Networks allow traffic filtering between subnets through the following approaches. So what are the approaches? Network security groups. There is something called NSGs. Define inbound and outbound security rules to allow block traffic based on IP addresses. Which IP address you would like to block. So all these things can be done using network security group, NSG. Network virtual appliances use specialized VMs that perform network functions like firewall or WAN optimization. Connect virtual networks. You can link virtual networks using following methods. One is virtual network peering. What does that mean? Connect to two virtual networks directly, allowing private network traffic to travel securely over the Microsoft backbone without using the public internet. It enables cross-region communication, virtual network peering. These are the terms. User-defined routes are called UDR. Provides control over routing tables, allowing you to manage network traffic flow between subnets and virtual networks. Okay, the important terms to make note of. The next thing is exercise. Configure network access. Now for this, you have to come to the learn.microsoft.com to this topic, describe Azure compute and networking services. Here, let's click on exercise, configure network access. I'm going to click on this. Now when I click on this, the very important part here, before you start verifying your account, you might have lost, like for me, the VM that I've created previously is already gone. Okay, so how I can verify? If I go to portal.azure.com, just check if the VM that you created previously still exists or not. So here if I see, there are no resources. If you see, there are no resources at the moment. So what I will do, let us go back. So here it is clearly written, if you receive an empty response, you need to complete the first exercise in the module again. If the result lists your current VM and setting, you may continue. So if it doesn't list, then you have to go back and create your VM first. So let's do one thing. As for me, it is not there. I'll go back, and the very first exercise we had in this one, create an Azure virtual machine. So let me first click on this. Okay, verify your account. Let me verify the account. So I have to find 4 stones. 3, 2, 1, 2, 3, 4. So this is the correct one. So I'm going to submit. Verification complete. Now let's create the virtual machine once again. Okay. So it is creating the VM for me. Let's wait for some time. Okay, so the sandbox is now activated. The time remaining 59. All right, let's wait for some time. Requesting a cloud shell. Requesting a cloud shell succeeded. Connecting to the terminal. Okay, so now it is ready. Now look at it. Let's go through this once again. In this exercise, you create an Azure virtual machine and install nginx, a popular web server. We saw it last time. In this instance, you are going to use the Azure command line interface. We'll create the VM not from the portal.azure.com, rather using a command line interface. We are going to create it. Okay. Now for this, the very first command that I have to copy is this. So let me copy this and simply paste it here. And to paste, you have to use Shift and Insert and hit on Enter. Command not found. Let me try again. Shift, Insert. Okay. Now hit on Enter. Okay. Now it started working. Let's wait for some time. So here I'm trying to create a VM. Okay. Azure VM create. So it's running now. Your VM takes few moments to come up. You name the VM as my VM. Okay. So now it is created. Run the following AZ VM extension set command to configure the software. So I'll just copy this code and do a Shift, Insert and hit on Enter. Okay, now it is trying to install the software into it. Okay, the nginx web app server software. Okay, so I'm installing the web server. Wait for a few minutes here. So this is complete. So once this code has run, this command uses the custom script extension to run the bash script on your VM. The script is stored in GitHub and it has installed the software. Okay, so this is done. Now let's go to portal.azure.com. Okay, now if I wait for some time, and here in the, if I click on the resource groups, okay, I can see the resource group is there. And if I go back, view all resources. Okay, so the VM is now created and the software is installed. Once this is done, let's go back to the next exercise. The next exercise is this exercise, configure network access. Okay, let's go here. Okay, so the sandbox is there, it's active. Now we have to follow this. So what it's saying, to verify the VM you created previously is still running, use the following command. So let me copy this. Okay, just wait for it. Requesting a cloud shell, succeeded. Connecting to terminal. So here all you have to do, simply copy paste the commands and see what's happening. So the first one, let me Shift, Insert and hit on Enter. Okay, so now if you see what it says, if you receive an empty response, you need to complete the first exercise that we have already done it. If the result list of your current VM and settings, you may continue. Right now, the VM you created and installed in Nginx on isn't accessible from internet. You create a network security group that changes. So now that software that we have installed is not accessible from the internet. You create a network security group that changes that by following inbound HTTP access on port 80. So you have to follow a couple. So here you can see the VM and the output has come, AZ VM list, and it has listed the output. So you can see my VM. Okay, so it has given the output. Now the next thing that I have to do is follow the task one. Access your web server. In this procedure, you get the IP address for your VM and attempt to access your web server homepage. Run the following command. Command to get your VM IP address and store the result as a bash variable. So what I'm doing, I'm simply copying this and I'm going to do a shift insert and hit on enter. Okay, so it has happened, it has executed. Now the next thing, run the following curl command to download the home page. So copy this and paste, shift insert to paste and hit enter. Okay, I think it did not work properly. Copy it, shift insert, hit enter. Okay, so this is done. So what happens here? We got an error, failed to connect to 172 178 139. This is port 80 after 5002 ms timeout reached. So here it said run the following command. The connection timeout argument specifies to allow up to 5 seconds. So here we have said connection timeout 5 seconds for the connection to occur. After 5 seconds, you see an error message that states the connection timed out. So we saw this 5001. You see 5002 millisecond timeout reached. So we got a similar this one. Now this is the output. Okay, this is the output we got. This message means that the VM wasn't accessible within the time out period. As an optional step, try to access the web server from web browser. Run the following to print your VM IP address to the console. Okay, so for example, let me copy this and shift insert, hit enter. So this is your IP address. Run the following to print your VM's IP address to the console. You can see the IP address something like this. So we got an IP address. Copy the IP address that you see to the clipboard. Okay, so I'm going to copy this 172, the IP address that's shown here. I'm going to copy, open a new browser tab and go to your browser server after a few moments. So I'm just have to paste, for example, this was the IP address, right? 23.102.42.235 in that example. So open the new browser tab and go to your web server. After a few moments, you see that connection isn't happening. If you wait for the browser to time out, you see something like this. So let's open a browser tab and try to access this particular IP. So wait for some time. So you can see this site cannot be reached is what I got an error. Okay, so the same thing happened, cannot reach the page. Keep this browser tab open for later. So let it be there like this. Next task, list the current network security group rules. Your web server wasn't accessible. To find out why, let's examine your current NSG rules. So for this, run the following command AZ network NSG, network security group list, command to list the network security group are associated with your VM. So simply copy this and I'm going to shift insert and enter. Okay, just wait for some time. So once this command is run, you see this output, my VM NSG. Do you see this output has come? My VM NSG. Every VM on Azure is associated with at least one network security group. In this case, Azure created an NSG for you called my VM network security group. If you go to portal vm.azure.com. Here you see my vm.nsg, the network security group is created. Okay, fine. Now next, run the following command to list rules associated with the NSG named by my NSG. So all you have to do, simply copy this code, and I'm going to do a shift insert and hit on enter. Okay, so I have entered. You can see there are certain output we got, like access allowed. Okay, destination address prefix star, ETG priority 100 protocol TCP, right? Provisioning state succeeded. So we got certain output. So once we have run this command, so the command that we have run is AZ network NSG rule list. So we have done this. Let's scroll down. You see a large block of text in JSON format in the output. In the next step, you will run similar command that makes this output easier to read. So for this, run AZ network NSG rule list command a second time. This time use query argument to retrieve only the name, priority, affected ports, access allow. So only few things I want, not the everything, right? There are so many things here. So I'll copy this and shift insert enter. Now let's see how the output differs from that. So now you can see the output is more readable. So name is default allow SSH, secure shell SSH, priority 1000 port 22 access allowed. So we got certain output. So something like this, we got the output. You see the default rule, default allow SSH here, allow SSH, right? This one. This rule allows inbound connection over port 22. Is a protocol that used on Linux to allow administrators to access the system remotely. The priority of the rule 1000, rules are processed in priority order with the lower number of processed before higher numbers. Okay, so we got priority as 1000. By default, a Linux VM's network security group allows network access only on port number 22. Remember, in Linux it happens on the port number 22. This port enables administrator to access the system. You need to also allow inbound connection on port 80, which allows access over HTTP. Okay, now task 3, create a network security rule. Here you create a network security rule that allows inbound access on port number 80 for HTTP request. Run the following command to create a rule called allow HTTP that allows inbound access on port 80. So for this, I'll just copy this command and enter it, shift insert and hit on. I think there's something wrong with, okay, command not found. Let me do it again. Copy, shift insert, enter. Yeah. So now it's running. Okay, it has run. For learning purpose, here you set the priority to 100. In this case, the priority does not matter. You would need to consider the priority if you had overlapping port ranges. So this is the priority 100 we have set right here. You can see. So now it has succeeded. Okay. After that, what to be done? To verify the configuration, run AZ network NSG rule list to see the updated list rule. So let's copy this. Shift insert and enter. So here you can see allow HTTP priority 100 port number 80. So now there are two ports are enabled. The first one we enabled 22 port and the second one for HTTP communication. I mean on a browser if I have to see. So I have allowed it. Okay, done. So once this is done, you see both the default allow SSH rules and your new rule allow HTTP. So you got both the things. Fine. Task 4, access your web server again. Now that you configured network access to port 80, let's try to access the web server a second time. Okay. After you updated the NSG, it may take few moments before the updated rules propagate. Retry the next step with pause between attempts until you get desired results. So let us wait for some time and then try this. Run the same curl command that you ran earlier. Okay, so I'm going to use the curl command, copy and then shift insert, hit enter. So this time, last time it has timed out. Now if you see HTML body, welcome to Azure, my name is my VM S2. So we got the output. Okay, we got certain output. It didn't time out this time because you have enabled the ports 80 and 22 port. Now once this is done, you see this response. Okay, we saw it. As an optional step, refresh your browser tab that points to your web server. You see the home page. Now here what I will do, last time this is what it was coming, I'll refresh it. Going to the web browser and trying to refresh. Let's see what happens here. Somewhere it is not loading. So if this is happening to you, do one thing. Let's close this. Go back here and try to get the IP address once again. So I'll go and shift insert, hit enter. So I got this IP address. I'm going to select the IP address carefully, right click, copy. I'm going to open a new browser tab, paste it and hit on enter. Okay, so when I do this now, welcome to Azure, my name is myVM. If the previous browser tab is not working, try this out. Just close it and open a new browser tab. Now you can see it has the website is now accessible to me. Welcome to Azure, my name is myVM. I'm able to access. So with this entire exercise is complete. Okay, nice work. In practice, you can create a standalone network security group that includes inbound, outbound network access rules you need. If you have multiple VMs that serve the same purpose, you can assign the network security group to each VM at the time you create it. This technique enables you to control network access to multiple VMs under a single central set of rules. Okay, now the sandbox will automatically clean up your resources when you are finished with this module. When you're working in your own subscription, it is good idea at the end of the project to identify whether you still need the resources you created. Resources that you leave running can cost you money. You can delete the resources individually or delete the resources group to delete the. Anyways, we are using a sandbox, so no need to worry about it. So now if I go back to the course, we have completed our exercise. So this is one of the exercise, right? Exercise configure network access completed. Now what is remaining? Describe Azure Virtual Private Networks, describe Azure ExpressRoute, describe Azure DNS, and there is a knowledge check. The next topic is describe Azure Virtual Private Networks. What is a virtual private network? In short, it is known as VPN. VPN enables secure communication between networks over an untrusted network such as internet by creating an encrypted tunnel. Most of us might have already used VPN. If you are a working professional, you might be aware of that. To connect to client machines, we use VPN. We connect through VPN. It protects sensitive data from attacks. Now VPN gateways. A VPN gateway connects on-premises data centers, individual devices, and virtual networks over encrypted tunnels. So the key word to remember is it is an encrypted tunnel to secure the data flow. Types of connectivity. So we have seen this earlier, site to site. That means connects on-premises data centers to virtual network. This is the word it is used called site to site. Point to site connectivity means connects an individual device to a virtual network. Network to network means connects virtual networks to each other. These are the three important terms to take a note. Azure allows only one VPN gateway per virtual network. How many? One VPN gateway per virtual network, but supports multiple connection. So you can have per virtual network, I can have only one VPN gateway. Now, what are the VPN types? Policy-based VPN, static IP addresses for encryption, suitable for simpler connection. There is something called policy-based VPN where I'm using static IP addresses. Route-based VPN where we'll be using routing protocols to select tunnels for data packets for more resilient and preferred for complex connection. So policy-based VPN, route-based VPN. Policy-based use static IP, route-based VPN is used for complex connections. High availability options. So for example, active standby. So these are the couple of terms you should be aware. What is the meaning of active standby? One instance active and the other is at standby. If something goes wrong, then the other would work. Automatically takes over in case of a disruption. If there is one fails, the other starts acting. That's called active standby. Okay, and these are the high availability options. Next is called active. That means two VPN gateway instances running simultaneously for redundancy. Both are running, okay, to manage the load and things like that. ExpressRoute failover. So VPN as a backup for ExpressRoute. You have your own private network path to get into it. So ExpressRoute to ensure connectivity during failure. So this is just for the ExpressRoute failover. Zone redundant gateway deploys VPN gateways across different availability zones. We learned about this in the initial chapters, availability zones for added fault tolerance. So these are different high availability options that is available with the Azure Virtual Private Networks. So the next topic is to learn more about Azure ExpressRoute. So describe Azure ExpressRoute. So what is Azure ExpressRoute? Azure ExpressRoute is a private connection. If the only word I have to remember, then private connection that extends your on-premises networks into the Microsoft Cloud through a connectivity provider called ExpressRoute circuit. It offers secure, reliable, and high-performance connection to Microsoft services like Azure and Microsoft 365. So ExpressRoute is nothing but a private connection to make it more secure. Features and benefits, let's see. Private connectivity does not use the public internet, first point, providing enhanced reliability, speed, and security. Reliability, speed, and security. Global connectivity. Access Microsoft Cloud services across all regions with ExpressRoute global reach. Okay, these are the couple of features and benefit of Azure ExpressRoute. Dynamic routing. It uses something called BGP. Now remember this term, BGP means Border Gateway Protocol. Border Gateway Protocol to exchange routes between on-premises networks and Azure. Dynamic routing, okay, this is called BGP, Border Gateway Protocol. These are the terms just we have to make a note of. The next feature is built-in redundancy. Provides reliability with redundant devices at peering locations. Connectivity to Microsoft Cloud services. Direct access to services such as Microsoft Office 365, Microsoft Dynamics 365, Azure Virtual Machines, Azure Cosmo DBs, Azure Storage, etc. Okay, so these are the couple of things to make note of. Connectivity models. Now it has got multiple connectivity models. One is the Cloud Exchange co-location. What it means? Data center connected at a cloud exchange for a virtual cross connect. So data center connected at a cloud exchange for a virtual cross. So virtually you are cross connecting the data center and the Azure cloud. Point-to-point Ethernet connection. Direct connection from facility to Microsoft Cloud. Even that is possible. I can connect my facility directly to the Microsoft Cloud through Ethernet. So you have your own private network. Any-to-any network integrates wide area network one with Azure for office and data center connections. Okay, these are different connectivity models Azure has. Direct from ExpressRoute sites. Connects directly to Microsoft's global network with high-speed connectivity of 100 Gbps or 10 Gbps. So these are the different connectivity models that are available. Now security, how it provides security? Data does not travel over the public internet, reducing risk, but certain Azure services like DNS queries may still use public networks. Our last topic in this module is describe Azure DNS. Now what is Azure DNS? Azure DNS is a service that hosts domains and provide name resolution using Azure infrastructure. So for example, I have a domain, let's say automate-with-rakesh.com. Now that is a domain name. I have a domain name. So people won't remember IP addresses. People would remember your name. We call it as a domain name. So Azure DNS service, it will host your domain so that everybody in the public for your company or for whatever the purpose you have created it for, you will be able to access it. So DNS records for your domains using the same tools, APIs, and billing as other Azure services. Okay. Similar way, like Azure has other services, this is also one of them which you can use it for hosting your domains. What is the benefit of Azure DNS? So it's reliable, performance, security, all these things are part of this, hosted on Azure Global Network and using Anycast networking for fast performance and high availability. Azure RBAC means Azure Role-Based Access Control. Azure Role-Based Access Control, activity logs for monitoring, resource locking to prevent accidental changes. All these things are part of the service. Ease of use. Managed through Azure Portal, Azure PowerShell, Azure CLI. You have all different options. It is integrated with your Azure billing support, and you have credentials. Customizable virtual networks you get. It supports private DNS domains for custom domain names within your private networks. Okay. So all these features with the domain naming service, you get it. Now, don't think the domain naming service generally to get a domain, you have to actually reach out to a third party where you buy. There are different DNS where you know all the domain names they sell it. So you have to actually get the domain name from there, and then here you can host it. Okay. Uh, Alias records allows you to create aliases records that automatically update if the IP address of an Azure resource changes. Okay. Public IP address, traffic manager profile, CDN endpoint, and all those things. Okay, so this is a very important point here. Azure DNS does not provide domain name purchases. You can use app service domains or third-party registers for domain purchase. Don't think using Azure DNS you are going to buy a domain. No, you will buy a domain from a third party and here you will be hosting it and host them in Azure DNS for record management. Let's do a quick knowledge check. So let's see what is the first question. Which Azure virtual machine feature staggers updates across VMs based on their update domain and fault domain? So update domain and fault domain. Why you have a fault domain? So that your VMs are available all the time. So available, right? Availability sets. So the answer should be availability sets so that you can do all the. So if I have to update the VMs, I can do it at one domain, the other domain is running, and then run this domain and then go to other domain to update. So availability set should be the answer. Let's try the second question. Which Azure service allows user to use a cloud hosted version of Windows from any location and connect from most modern browser? So cloud, if you have an operating system in a VM, this will be a Azure Virtual Desktop. Virtual machines generally are blank. You install it. In containers, in one host machine, there will be multiple instances of app that would be running. So out of all this is the correct answer. If you need connections between virtual networks, point to site means one device to the Azure. Multi-site connection, from your data center, you want to connect with Azure data center. Coexistence with an Azure ExpressRoute gateway, your own private gateway. Which type of VPN gateway should you use? So policy-based VPN gateway, point-based VPN gateway. It's not just talking device to this one, right? So the best one is route-based VPN gateway. So you may have multiple subnets. So this is the best gateway to use for. So let me submit the answer. Did I answer all of them? Yes. Okay. Submit. All right. Let's see. Okay, this is correct. You should use route-based VPN gateway. They are more resilient to topology changes such as the creation of new subnets. Okay. Azure Virtual Desktop provides access to cloud-hosted version of Windows and it works most. Okay. Availability sets stagger VM updates based on their update and fault domains. Okay. So that's how it is. So if I hit on next, go to the summary. Okay. And hit on the complete module. So right now we have completed this particular module. Now what is next? Okay, let's go back a little just to see what is next after this. This is all completed. Got a green tick mark. So in this we were on Microsoft Azure Fundamentals, describe Azure architecture and services. And in this one, describe the core architectural component of Azure. This one we have completed. Describe Azure compute and networking services we have completed. The next two modules which are remaining, describe Azure storage services, and the next one is describe Azure identity, access and security. These are the two things we have to cover.